we landed. After yesterday. So what do we do though? We're going to take it up a notch. It says, what if there are functions of x in both limits of integration? So I'd like you to use your highlighter. And here's, whoops, what you're going to do. Maybe. There it is. So let's highlight that piece. So all you're going to do is what we did yesterday. And let me point this out up here at the board. Do you see that if I had a constant and I had g of x, I did f of g of x times g prime. Whoops, what happened there? Can you see the whole thing on your screens? Okay, I don't know why it's doing that. All right, so what I want you to do is we're gonna just cross this out. I don't know why I put that on there. So here's what you would do. You would take f of the top times the derivative of that top minus f of the bottom times the derivative of the bottom. There is a homework problem just like this one. So don't be alarmed that you can't do any more with it than that. So let's look at example 10. Let me do this one with you, then I'll let you do 11 on your own. So if I have f of x equals the integral from 2x to 3x of t squared minus t dt, and I want to find f prime of x. So, big idea from yesterday is the derivative of an integral, they're inverses, so they knock each other out. So then what I do is I'm going to replace the t with 3x, and then I have to employ the chain rule and take the derivative of the 3x minus, and I'm going to do the same thing now with the bottom. So this will be 2x squared minus 2x times 2. And let me pause a brief moment because that may not make a whole lot of sense right now. And this will make a lot more sense a little later. But let's say the top function is g of x, and my bottom function is h of x. Here's kind of the big idea why I'm doing this subtraction. Is, do you understand that if I did the integral of g of x, that's everything under g of x? But then when I do the integral of h of x, you see I've double counted this bottom part. You see it's in here and then it's in here. So I have that area under the h of x twice. So that's why I'm doing the subtraction there. So that's the why. So let's go back and tidy this one up. This is going to give me 9x squared minus 3x times 3. 4x squared minus 2x times 2. So I get 27x squared minus 9x minus 8x squared plus 4x. So I know I'm going a little bit fast, so start returning stuff. Stay with me. All right, so on this one, did you get 19x squared minus 5x? Yes? Okay. So go ahead and try example 11 on your own. Let's see if you can do that one the whole way. All right, so I'm going to go ahead and start this one. My function isn't showing up. H prime of x is the square root of 16 minus x cubed squared times that derivative, which is 3x squared, minus the square root of 16 minus 3x squared squared times 6x. Now the good news is when you're trying to do h prime of 1, I only need to plug in that 1, so that's 3 square root 15 minus 6 square root 7. How many of you got that? Yes? Okay, good. All right, now let's do the last one. It says in example 12, you're given the graph of f of x below. Find the solution to each of the following definite integrals. Use the provided graphs to resketch a graph, which I actually did, but then we can depict where the integral area is. So in letter A, I'm asked to do the integral from -4 to 0 of negative f of x dx. Well, one of the properties we're going to learn is that if there is a constant in front of the function, you are allowed to pull the constant out. So, I mean, if this had been 3 times f of x, -6 times f of x dx, I could have pulled the constant out. So since it's a negative, really a -1, I can pull it out front. So, if I'm going -4 to 0, watch what I'm going to do. Then this is negative. I have a quarter of the circle. The radius is 2. Then I have a teeny tiny little triangle. So go ahead and compute that. All right, so in this one, I got negative pi plus 1, and you could, in fact, distribute. Now in letter B, I have from 2 to 6, so you want to pay attention to the limits of integration. What do you remember about absolute value of a function? What does that do to the y values? It makes them positive. So watch what's going to happen. What that's doing is it's going to take this piece that's below and flip it above. So that's going to give me 1/2. I have a little trapezoid here, plus 1/2 my base times my height. So that's 3/2 plus 2. which is 7/2.